Okay, hi everyone. My name is Howie, and this presentation is about Scala scripting. The title of this presentation has evolved over time as I've been working on it. So as of now, the title is Making Scala Scripting Actually Good with Mill. So about myself, I've been working on open source Scala projects for over 10 years now. Who here has used any of the projects like listed on this page? Who here has used Ammonite? Who here has used Mill? Who here has used uPickle? Okay, great. So most of you are already familiar with most of these projects. I won't go too deeply. Apart from my open source work that you've probably seen before, my professional expertise is developer tools. So IDEs, CI systems, testing systems, build systems, cloud, dev environments, all that sort of thing. But for today's talk, we are going to talk about Scala scripting. Scala scripting is something I've worked on for quite a while. I think I gave my first talk on Scala scripting in 2015, which is 11 years ago. And it has always been kind of there, but also kind of not there. It's cool enough to show on a slide, but not good enough to actually use. Even for myself, after playing around with it, I didn't actually write many Scala scripts. And this talk will walk through kind of the history of Scala scripting over the last 20 years, what it's like, what's there, why it's not been good enough for even me myself to use, never mind everyone else, and why I think we have something better today. So why would you care about JVM scripting? So everyone needs small scripts at some point in time. Bash can be very fragile to read and write. Python can be very hard to deploy reliably. If I have a Python script and I give it to all of you, there's 0% chance it'll run on all of your laptops without something blowing up. Performance and parallelism can be a big deal for scripts because everyone has found scripts that are slow, not because the thing they're doing is complicated, but because the script is inefficient and not optimized. But also, type checking can be surprisingly important for scripts as well, because small scripts are often the worst tested parts of your code base. Your scripts will have no unit tests, no integration tests, and you want to go work on them, and there's no way to know whether to blow something up. And having a type checker really just gives you a bit of safety when you're working on these scripts to work on them without screwing up. And of course, the JVM library ecosystem is huge. You can find a lot more on Maven Central than you can access from your random bash command. And there's so many libraries out there to do all sorts of things, whether dealing with docx files, whether talking to Kafka, whether downloading stuff from your Postgres database. And all of that's available for you to use in your JVM scripts. So all of this sounds good, so why doesn't anyone actually do it? And we'll go through many of the attempts to make JVM scripting happen over the years, why they have failed to make JVM scripting happen, and why I think we can maybe now actually make JVM scripting happen. So to begin with, you can just run Java programs using the Java command. You don't need Java C anymore since I think 2014 or 2015. And you can just you have a Java program such as this, so this is an example program with a small graph in memory, and it runs a breadth first search over the graph. And you can run this by java test.java. Let's say I give the start node in the graph, give it the depth I want to traverse my breadth first search, and it'll run this code in memory and print it out. You don't need to run Java C and Java separately. You don't need to worry about class files. Just run java test.java, and it runs your Java code. So all of this is great. Except when you realize that you can't actually do much with a single Java application, a single Java file. For example, maybe for one, the syntax is kind of clunky versus what you'd be used to in Python or Bash. You cannot easily download third-party libraries to use. Like when you run Java test.java, you don't get anything except the standard library, unless you're going to go curl down some jars from Maven Central and add them to your class path manually, which no one actually does because they're a pain in the neck. Doesn't support multiple files. Doesn't have any useful built-ins to use in your program. Like you often want to parse command line dargs. You often want to read and write to files, make HTTP requests. Java standard library has nothing for command line dargs and kind of clunky ways of reading and writing to files and making HTTP. Surprisingly, the IDE experience works. So if I go over here to my example Java program, there's no IntelliJ module, Maven module, Gradle module set up here, but I can navigate around the Java standard library and jump around this program in my IntelliJ and probably VS Code. So this works. And lastly, larger project integrations don't work. So one thing you often want to do in scripts is make use of the code you already have in some microservice or some library or some monolith. You want to use a SDK you already have in your monolith rather than curling things directly using HTTP. But when you're writing a Java program like this, you cannot use any of your existing code base to do your thing. And that's all of this means that although this is a cute demo for students or cute demo to show on a slide for testing out language features, no one's actually going to do it. So next is Scala foo.scala, which from my historical analysis came out 20 years ago when they added a Scala command that could run scripts separate from the Scala compiler and separate from the Scala REPL. So Scala foo.scala is a bit more concise than Java foo.java. So you can see the Scala code has a lot less lines, it's a lot less horizontally spaced out. But everything else still doesn't really work. You still can't use third-party libraries, you still couldn't support multiple files, you didn't have any useful built-ins, you couldn't do other things like assemblies or whatnot of your Scala script. IDE support now has stopped working because that's just the way it is in Scala with IntelliJ, without a build tool to intermediate. And again, you can't really integrate with any larger projects. So your Scala script is a standalone thing, great for learning about algorithms 101 in school, not so great for doing any real work in your real enterprise code base. So something that some of you may know is you can run scripts using SBT. Has anyone tried this? So you can actually put a shebang line which says user bin end with SBT script main, put in your SBT config at the top of your file, and you can run it. Like in this case, you can actually start using third-party libraries here, which is quite nice. So I can say this is Scala version 2.13.12. I have a library dependency on JSoup. So now I can, for example, instead of using this in-memory hard-coded graph I showed you earlier of dictionaries and lists, I can actually start traversing third-party data sources. In this case, my script is now going to traverse the Wikipedia article graph using JSoup, which is a third-party Java library, to connect to Wikipedia, download the HTML, parse out the main paragraph anchor links, grab their href links, and let us get the graph of Wikipedia articles out from this particular single Wikipedia page, or get the edges of outgoing Wikipedia pages. So these edges form a graph, which I can then traverse. So I can show you this in the code. So this looks like this, and if I go down here, so if I go out of my Java, I go to 2sbt, I can just do /mil html scraper.scala, /html scraper.scala. And it's a bit slow because SBT is kind of slow. Oops, I need to pass in some arguments. Like let's say I pass in hello as my start article and a depth of 1 for my breadth first search. So you can see this gives me all articles within depth of 1 starting from hello on Wikipedia. I can pass in depth of 0, which will give me just my root article on Wikipedia, which is the article hello. I can pass in depth of 2, and this may take a while because it's going to have to make a bunch of HTTP requests. So this works. The IDE support maybe still doesn't quite work out, but you can run this. So although this has some advantages over what we saw earlier, in particular, the fact that third-party libraries work. So now we are no longer limited to standard library. We can actually make use of the robust Java or Scala ecosystem available on Maven Central. Many of the other things that people end up wanting to do in their scripts still do not. You can't have multiple files. For example, a script that depends on another script or a script that has a test suite. You don't have useful built-in utilities. You can see I'm just parsing my arguments using pattern matching. I don't have a proper argument parser. I don't have a proper HTTP client or proper file system library. I can't make assemblies out of these scripts. IDE support doesn't really work. In this case, it's just JSoup that doesn't work. I can't jump the definition here or get docs, but any larger script, you'll use more and more third-party libraries, all of which will have broken IDE support. And larger project integration, this won't really integrate into any larger SBT project. So in 2014 or 2015, my project Ammonite came out, which many of you probably have used. So Ammonite is a project that explores Scala scripting. Like, can you run a REPL? Can you run scripts? Can you use Scala to replace your bash terminal even? Like, can you run Vim in Scala REPL rather than running Vim in bash? Can you run ls in a Scala REPL rather than running ls in bash? In terms of writing and running scripts, it has many advantages over what was there before, using Scala, using SBT, and so on. For example, you could import third-party libraries using this import $iv syntax. You could use the @main annotation. So Scala 3 has it now, but Ammonite had it first, and Ammonite's one is better. For example, you can see that the @main on the main method, we automatically converts the 2 arguments into flags that you can pass in from the command line, including things like help text, including things like autocomplete, including things like option support and default value support and all those things. And it comes with some useful third-party libraries bundled together. For example, it comes with prettyprint, which is often very handy when you're trying to debug things in a script. It comes with oslib to read and write to a file system. Many of you probably used it. It comes with upickle to read and write JSON. Again, something very handy in many ad hoc cases. So there are a lot of advantages here. Like all this stuff is nice. And part of the original demo was, hey, I can just write a script that does something useful using third-party libraries without having to mess around with java.nio.file.files.read or java.io.url HTTP URL connection to download things from the internet. So Ammonite scripts are to some extent great. I can show you here in the REPL, in the editor, sorry. I can do Ammonite HTML scraper.sc. You see it compiles. You see I get a proper error message, including help text because of the Ammonite main method support. I can pass in def1 start hello. You see it pretty prints it out using the prettyprint library it has bundled. The actual script is over here. Other things you can see is that ID support doesn't work. And this has not been a constant. At many points in the past 10 years, it did work. At other points in the past 10 years, it did not work. And it's bit rotted. I've gotten it fixed. It's bit rotted again. But generally, it's kind of been pretty flaky to write scripts using Ammonite. So although in theory, this looks great on the slide, in practice using it, you still have a lot of limitations. Other build workflows don't work. For example, assembly doesn't work. Pre-compiling of scripts doesn't really work. One of the big design decisions for Ammonite was Ammonite started as a REPL, so scripts are treated as sequential REPL commands to run one after the other. This makes the scripts very dynamic. You can add compiler flags in one part of the script and user compiler flags in subsequent parts. But it also means that you don't really have the concept of, I'm going to take all this stuff, compile it, and run it later. Because fundamentally, it's treated as a sequence of REPL commands, any of which could do anything. And the compilation and running of these parts of the script are all interleaved and hard to separate. ID support doesn't work well, as I showed you earlier. Sometimes it did in the past and it got fixed, but now it doesn't. And doesn't really work in any larger project. So you can't easily say, I have an SBT project, I have a big monorepo somewhere, I'm going to use Ammonite just in this small script to use the libraries in the project to do things. So many of these problems are a lot more fundamental than you would expect. And when we looked at Ammonite a few years ago, we realized that some of them are simply unfixable. So this is a ticket I posted on Ammonite GitHub a while back. So Scala CLI by 2023 now exists. Ammonite's not the only script runner. Scala CLI does it better in many ways. You can pre-compile a script using assembly, build assemblies, and so on. Ammonite shell, which was an attempt to use Ammonite as a bash shell replacement. So you can write ls and cd in your Ammonite shell. That was a dead end. It didn't really work out. The dynamic script running strategy, treating the scripts as a sequence of REPL commands, was quite clever at the time to reuse all of Ammonite's REPL features. But again, it proved to not really work out. It means you can't, because of the script compilation and script running are interleaved for every single statement, it doesn't let you do a lot of interesting things you want to do your scripts. Like you want to test your scripts, you want to deploy your scripts, you want to assemble your scripts, build a native image of your scripts, you want to resolve your Maven dependency for our scripts to see what gets resolved up front. All that cannot be done. So there's a bunch of things that we basically found that we couldn't, even though Ammonite was a nice prototype, it was never going to get really good. And I think at this point in time, we've gotten to a point where you no longer need Ammonite, and we are actually going to get rid of it. So by get rid, we're not going to delete it, but we are going to deprecate Ammonite going forward, because for Scala scripting functionality, Scala CLI and Mill both have better scripting than Ammonite has. And for Scala REPL functionality, we actually have upstreamed almost all the useful parts of the Ammonite REPL. So things like Control-C handling, pretty printed output, dynamic import libraries. All of these are present in Scala 3.8.2. So if any of you want to use these libraries and you're stuck on an old version of Scala, if any of you like Ammonite and are stuck on an old version of Scala, you should just update to the latest version of Scala and deprecate Ammonite. You just update to the latest version of Scala, and you have all the Ammonite niceties built in the default Scala REPL. So if I can go, I'll show you that later. So, okay, Ammonite was a great attempt. It didn't really work out. Even I didn't end up using Ammonite scripts much beyond the initial exploration. The next thing that came out is in 2021, where we had Scala CLI, which is basically a reimagining of the old Scala command that's now also called Scala, which is slightly confusing, but probably it's fine. So Scala CLI lets you do a bunch of things much better than Ammonite did. It fixed a lot of problems. For example, you could now set your JVM version and dependencies in the header comment. It used a very similar main method as Ammonite, though not quite as good. You can see it no longer takes in the --def flags. You can see that we no longer have pretty print and OSLib and other things available in the REPL by default. Yeah, you can add it using a toolkit or add it as a dep up here, but it's not available by default, which is kind of inconvenient for people who just want to write a script to do something. But it does have many things that are good. Like, for example, you can assemble an Scala CLI script into binary, compile it without running it, take the assembly jar, and run it later, which is something that we could never get working with Ammonite. It's impossible given Ammonite's REPL heritage and the way the scripts were treated as REPL statements. Support for third-party libraries works, which is great. Other build workflows work. Maybe it doesn't support everything the SVT supports as a build tool, but supports quite a lot of things, which is pretty good. So Scala CLI was definitely a big step up over what we had before, over Ammonite. But there are some issues that I think aren't quite as polished as I would like, and that's where I think nil scripts come in, which are a new feature that nil we launched in January this year, and it aims to really make the experience writing scripts in Scala really, really, really good. So for those of you who have used nil, you'll know that nil is traditionally configured using this Scala DSL, which is kind of cute. It's like, you have a package object extending a Scala module. You have some methods that define the configuration tasks or the computation tasks. You can compile, run, assemble, test, all your standard build tool things, nothing special. But if you're just wanting a very simple program which doesn't really need any custom tasks or custom like build tool chains or workflows or pipelines, all this stuff here is just boilerplate. Like, I just want a Scala module with Scala versions 3872, whose Maven dependency is org JSoup 172. All this package build, import, object package, def, Maven, prefix, string interpolator thing, seek, all that's complete boilerplate that I do not want to look at. And I'm sure many of you who've used SVT are used to programmatic build, so maybe are used to this. But there's a whole other part of the universe which is using tools like Cargo, which is using tools like Go Build and so on, for which all of this is actually a lot of boilerplate compared to a cargo.toml file, for example. So if you strip off all the boilerplate, this is the actual info that's important in my mill build. Mill in the latest version of 1.1.5 supports declarative builds, which look like this. Basically, I have a YAML file, build.mill.yaml instead of build.mill. It contains only the metadata, and it does all the same things and supports all the same two tasks that your Scala code did. And it's basically a one-to-one mapping. The extends becomes extends, Scala version becomes Scala version, Maven becomes Maven. All of it's just directly mapped over and back and forth. So these two behave the same, work the same. The YAML is a lot more concise, and the YAML is much less flexible. So YAML does not let you write custom tasks, for example, whereas in the build.mill Scala code, you actually can write a custom task with some Scala code to do something. YAML, you can't put code in there. So but for simple projects, which is perhaps many of the projects in the world, these YAML files may be enough. And for those of you who like Cargo or like these more declarative build config, this is probably much better suited for you. Mill declarative build support most build tool features. So you're not just a toy, like basically every single thing that Mill supports you can configure using declarative build, whether it's Maven Central Publishing or custom source folders or Java options or whatnot. The only thing you cannot do here is custom build logic. And all of this stuff maps very directly to the old style Scala code. So, extends becomes extends, Maven depth, which is a list, becomes a seek. JVM version, which is a string, becomes a string, or number, doesn't really matter, becomes a string in the end. I can append things using this YAML tag. Fork end, which is a JSON map, is a fork end Scala map. So it's really a one-to-one mapping, although the syntax is a bit different and maybe a bit more concise, but less flexible. You get all the same features. So you have these declarative mill builds. And if they're really small, and why don't we just put them in the same place as the code? And that's where our mill scripts came from. So we already know it's a Scala file because of the extension. We're already going to have a default Scala version. We don't really need that. Just use the default unless you really want to customize yourself. And that's where you can write a mill Scala script. So this is what a mill Scala script looks like. I can show it to you in the command line. So here's my mill Scala script. I can go 5. I can do /mill html scraper.scala. I can pass in start, hello, depth1. You can see it works. I'm passing depth 0. It doesn't do any scraping. It's really fast. You can see a no up takes about a few hundred milliseconds, much faster than SVT or Scala CLI script you were trying to run earlier. And with the mill Scala scripts, it really fixes many of the long-standing problems that we've had with SVT scripts and Ammonite scripts and Java single-file programs and Scala, the old launcher, and the new Scala CLI, which still has some limitations. You get a concise Scala syntax. You can get access to third-party libraries. You can customize things like JVM version. In fact, you can customize almost anything here. You get all the useful built-in libraries like PrettyPrint and OSWrite and upickle and so on. You can do all your build tool things as well because mill Scala scripts are mill modules. So you can do assembly, you can show Maven depth trees to debug your Maven dependency resolution and evictions. All that stuff works. And if I go to my IDE, you'll see that my IDE works. So I can jump to definition, I can pop up my docs here. And this is not something I loaded specifically for this script. This is just a random mill build that has this script in it. It gets picked up, loaded into IDE, and it just works. So, and it comes with all the third-party libraries, things like PrettyPrint, things like OSLib, things like upickle. You can turn it off if you want, but for most scripts, you probably don't mind them having them around. They're very handy, so by default, they are all included. And from these mill Scala scripts, you can then do everything that you can do with your Ammonite scripts, but in a much more comfortable manner. For example, if I go to Scala script use cases, let's say I go to my JSON API client. You can see this is another script that does a JSON traversal of Wikipedia's article graph using its JSON API. I can run it from the command line. Whoops, I don't have my mill script here. I need to /. Let's go use a project's root mill script. Yeah, you can see that it's quite nice to run. I get good ID support for everything. I get multiple scripts in the same folder. I'm going to use def1 so it doesn't take so long, because otherwise it'll take a while to make all those sequential requests. You can see that if I do autocomplete, you can see all the different things that your mill build allows you to do on this script. For example, you can make an assembly, you can compile it ahead of time, you can create a Scala console that has access to this script. I think it's here. So let's say I make a console. You'll see that now I have a console with my script ready. And you'll notice that all my Ammonite features have now been ported to the upstream Scala console. So this looks like Ammonite if you've seen it before, except it says Scala rather than Ammonite. And this is actually Scala 3.8.2 just bundles with this. We took the Control-C handling, we took the pretty printed output, we took the nice syntax highlighted input, We took the dep support, so I can use dep to import libraries. We just ported all these upstream Scala console, so you have these available. And basically anything you do with your Ammonite scripts or your small Scala programs, you can do with mill scripts. You can run web servers, like here's a small Cask web server. Let me just copy paste the command. Tree web server. Run background. So here's a small script. You can see that because I declared this dependency in the YAML build header, I now get full autocomplete and everything in my build. I run background and I can interact with the web server from the terminal. And even in a very large project, for example, here's the mill code base. Mill itself is a Scala monorepo with maybe 100,000 lines of code in 100 different submodules. And I can just open up a random script. Let me just show you one in here. I can just open up a random script, and I get ID support for it. Everything is loaded as a separate IntelliJ module or VS Code module. So if I look for foo.scala in here, you can see the script with all its dependencies loaded and ready for your ID to use. And perhaps lastly, I think, these are interesting things. You can make a static site generator. You can write some database, do some database actions using Scala SQL. If any of you haven't used Scala SQL, it's very similar to the USQL library we saw this morning, except it's a bit older. It came out 2 years ago. So mill scripts basically support everything that mill supports. And this is very different from how Ammonite works, or even for how much Scala CLI supports. Like Ammonite supported basically nothing. It's a REPL, it runs things one after the other, and that's it. You can run it, and that's all. Scala CLI has implemented a lot of this stuff through a lot of hard work. So you can do assemblies, you can do native images in Scala CLI, you can publish in Maven Central. And mill happens to support all of it basically for free, because we just take the scripts, we take the YAML header, and we feed it into the mill Scala build, and you get all this stuff already available. For example, you can have script dependencies and test suites, where I have one script here. I have another script that depends on this script via passing in its script name as a module dependency. It extends the utest feature, and I can run unit tests on that script just like that. So let me try and show this to you. If I go back to my mill build, so I go back to my mill script. Yeah, so you go here, you go here. So on the top is the HTML, is a HTML scraper script that we saw earlier. At the bottom is a test suite. If I go over there, who is this in? This is in Scala script runners 5 mil. I can do ./mil test HTML scraper.scala and run the unit test that will depend on fetch links. Here you can see the IDs, it lets you jump to it, jumps across the file, and runs a unit test for my script from another script. And you can arbitrarily change script dependencies. You have one script that depends on the other, All of this gets resolved just like any Scala module does if you have multiple modules that depend on each other, or you have multiple sub-projects in SBT that depend on each other. We basically turn each script into a sub-project or module semantically, but without all the heavy overhead of syntactically generating a whole bunch of SBT modules, or performance-wise trying to load a bunch of SBT modules and trying to make sure they run in the right order. So with mill scripts, you just write these files, they depend on each other, and you can do anything you can do with SBT build or mill build with these small scripts, but for these small scripts and small use cases, it's a lot more convenient. So yeah, so I think the way to look at this is, there's always been a spectrum between declarative and programmable builds. So like, who here loves SBT? Some people. Who here loves Cargo, if you've written Rust before? Cargo is pretty nice, right? And like, there's no right or wrong here. Cargo is defined using TOML, SBT is defined using code. And traditionally, it's always been a split. You have pom.xml, Maven Mojo. You have your Gradle properties and build.gradle. And it's always been a split between declarative and programmable builds. So mill earlier versions have always been on the super programmable side. Super flexible, it's quite complicated, and more pretty verbose. Maybe not as complicated as SBT, but pretty complicated. And MIL, now with 1.1.0 and above, you now have the whole spectrum available within your single build tool. If you want to use your programmable builds, you can. If you want to use your declarative builds, you can. If you want to use your scripts, you can. And you don't need to choose and be worried about choosing the wrong thing. You can use each one, even within the same code base, as it makes sense. So that's another presentation. The website's here. I hope you try these new features in MIL 1.1.0, and I can take questions.
Thank you for presentation. I have a question. If I catch that correctly, that MIL script doesn't have to be a single file script, but it can also import another file by this model dependency, so I can have multiple files, but I have to explicitly include them, or it could work with multiple files?
Yeah, let me show you. So over here, I'm going to write a new file that says like hello.scala, and I'm going to add a a module dependency on HTML scraper, and I'm going to say like print line fetch links hello, and if I then run ./mil hello.scala, it will then compile hello.scala, and it will depend on HTML scraper.scala, and it will make use of fetch links that we imported from there. So effectively, you can have these script graphs, and the way they are treated conceptually is they are just modules with a single file. So you have SBT modules that depend on each other, you have MIL modules that depend on each other, you have test suites that depend on test suites, or test suites that depend on non-test suites. It's exactly the same here, except each one just has one file in it. And the configuration lives in a header comment rather than in a separate build file. So you already kind of hopefully understand how this works, and you can use it for whatever. It's quite handy to be able to make these dependencies, whether for test suites or for shared libraries or other reasons. Yeah. Any other questions? Anton?
Thank you. For context, I've been using Ammonite for a long time, and the one thing that you mentioned, which is the IDE support constantly bit rods, that was sort of the main rubbing point over the course of the 10 years or whatever that I've used Ammonite. So my question is, with the existing 3 different ways to define MIL build, what is preventing the current IDE support from bit rotting the same way that Ammonite did over the course of its history?
The reason that that won't bit rot that badly is that they all go through the same code paths at the back end of MIL. So from IntelliJ's perspective, IntelliJ just thinks that this is a Scala module with a single file in it. IntelliJ doesn't know it's a script. IntelliJ does not need to know it's a script. And IntelliJ is able to navigate around both internal dependencies and external dependencies without having to know anything about Scala scripting. So assuming IntelliJ doesn't go and break my normal MIL IntelliJ support, the MIL declarative support and MIL scripting support should also just work. Yeah, over there.
Are you planning to also have IDE support for the declarative conflicts? Like go to definition to make an index, for example?
We are planning to, but we haven't added it yet. Okay. This is pretty new.
Okay, thanks.
Any other questions?
Right.
Oh.
So I have a question. If I have a project that's built with MIL, and can I write a script that will use modules defined within that project?
Yes. So I can just show this to you in our example suite. It's script, programmable module depths. So over here, I have an example project with a single MIL build with a single module named bar. And over here, I have a script that just depends on bar and is able to use my bar classes and bar functions within that script. And the script is just treated as a downstream module, so your parallelism, scheduling, and all the build stuff will just be treating it as a separate module, and it generally does the right thing.
Thanks for the talk, and I'm really impressed with the IDE support for scripts. Something that in Scala CLI we've had problems because we don't have multi-module support with Scala CLI. I find this really, really cool. The question is, can scripts depend on other scripts, and does it create any edge cases where IDEs go crazy? Because that's something I've definitely run into with Scala CLI supporting weird input configurations.
Sure, yeah, so scripts can depend on other scripts. That's what I showed earlier with my hello.scala depending on html_scripper.scala. I have to reload the BSP in order to make it pick up, but hopefully it should pick up fine. I think it generally just works because IntelliJ just treats it as a module rather than as a script file. Modulo your normal IntelliJ flakiness that sometimes happens with BSP. One edge case is that we allow scripts that do not have any header, and which can make script discovery in your IDE somewhat tricky. So we have a bunch of heuristics to try and avoid discovering scripts that shouldn't be the aren't scripts, and to try and pick up the scripts that are scripts, and generally it just works. But that's one of the edge cases where, because we support these kind of naked scripts, which are very handy to have, it can make the IDE support a bit more tricky if you have scripts that, or Scala files that do not live in normal SRC source folder. Yeah.
So if one script is reused by many other scripts, they are still each of them treated as a single module, and that's why you don't have overlaps and IDs just work.
Yes, so if I open up my BSP page here, you can see I have some modules, and I have a bunch of scripts, including Kotlin files and single file Java files, each of which are separate modules. And if you're wondering about things like Maven dependency resolution, if different scripts resolve different dependencies and you get combined in the same assembly, all of that is treated as if they're separate modules that get combined. So it uses a normal Corsair combination. The class paths get combined the same way as if they're separate modules. Basically, as long as separate modules work, separate scripts behaves exactly the same.
This is cool, thanks. I know what to play with. I will hijack one more question. Why YAML?
It works and it's fine. I mean, it is YAML, TOML, JSONnet, DAL, Q, whatever you want, right? Like, then you have to pick one. They all have their pros and cons. I pick YAML. Yeah.
Thanks. I'll continue with the YAML theme. I think it's a reasonable choice, at least if not the best choice. I think because YAML is such a widespread, has such a widespread usage, it's the most common thing to use, really. But to get all of the features of YAML, there needs to be a schema so that like IDEs can help with auto-completions, with the YAML configuration and so on. Is there already such a schema developed for Mail that describes the schema of the YAML Mail config?
We have the ability to get schemas from upickle. We have not wired it up to the IDE. So all the mill tasks that you can configure in a script serialize to JSON, they all use upickle to do so. Upickle does support JSON schema generation, but we probably can't wire it into mill until another breaking version because it requires to put a new derives clause on every case class and implicit to properly add the schema derivation. Yeah, because the normal upickle only generates a read and writes and doesn't generate any metadata. Yeah.
So we were saying it's coming.
Yeah, at some point.
Thanks.
Yeah.
I was wondering with the slow startup of Scala and with the no-op taking a significant chunk of a second, is there a way to deal with running the same script on every file in a directory if there's like thousands of files? Is there a way to like skip the startup or something?
Not really. I think a lot of it comes down to the fact that mill scripts are treated as modules, so they go through a whole like cache invalidation process and so on. So for example, if I have this standalone script and I do /mill hello.scala, it takes 0.22 seconds, and that's about as fast as you're going to get with all this infrastructure going on. I think the current idea is if you want to put logic, you can put logic inside the script rather than outside, where it will run exceedingly quickly on the JVM. But we can't really optimize this to be comparable to Bash taking 4 milliseconds to boot, for example, or a C binary taking 0 milliseconds to boot.
All right, thank you.
Okay, I would say I have to cut it off here with the time. Thank you so much. Round of applause.